So this is going to be called a taxing. So this is the sample data. Let's now calculate the average based on the probability distribution, which if you think about it is theoretical. We never saw 1/6 on any of these, did we? We saw close to 1/6, and I think Caitlin's going to agree with me. We're going to get 1/6 as close as we need to get, the more we do. So we'll just assume off to infinity, it'll behave 1/6 with no margin of error, small enough to be ignorable. Good? Okay? So now let's calculate the average, if you would, a theoretical average. This does fall very, very short, and you'll see starting in next class how falling, it's very easy to have this fall short right back in your face, and we'll see. But it works great for a dot. Okay, do you remember how to do a weighted average? Manually. I mean, yeah, one of our stats, L1, L2, boom, enter. Yeah, that's how we do it in the machine. But do you remember how to do it by hand? You can say no, of course.
Multiply our...
Go ahead, Lauren. I think it was you, right?
Like the 1 times the 40.
Yeah, you take your data and multiply it by the frequency of occurrence, and then add all that up. And then you eventually divide by the frequency of occurrences, all added together. And that's how, if you had to do it by hand, you would do that. But time out, we can't do that. We don't have a frequency column anymore. I just erased it. So we have to substitute some stuff in. X is still, X is still X. What are we now calling F?
PMX.
Right. F is now the relative frequency, or the probability, yes? So theoretically speaking, we have to multiply each X by its probability. Fair? And then that would also have to substitute in down here, wouldn't it? So all these F's just have to get changed to P of X's, because that's the new measure that we're using for frequency. Stop me if that doesn't make sense. Or ask me a question if you've got a question at this point. All I'm doing is a little teeny tiny bit of algebra, and that's substitution. I'm taking all the F's and making them the probabilities. So we're just taking one thing out and replacing it with what we're going to use next.
But, okay, so they're all the same.
Say that again, Ms.
But
Tasha.
they're all going to be the same.
Probabilities are all the same, yes. So what's on your mind?
Cancel out the problem.
Oh, careful. I like what you're saying, and that's the problem with algebraic symbols. It looks like we should be able to just go cross, and the P of X's go away. The problem with that is, if you were to write this out,
Oh wait, is that the sum?
it's the sums,
Okay.
not just multiplications, it's the sums. Hi. But here, do you notice anything about, this looks awful, yes? It looks terrible. It looks worse than this. But my contention is that it can actually be better. What are you thinking, Emily? No? No.
You say
You say that again?
She's like,
Oh, sorry. Yeah, I was getting low enough, I crashed my ass. What did this add up to with our raw data? Do you remember?
282.
282, right? Okay. What's that going to add up to? What's the summation of probabilities going to add up to? What's this column going to add up to?
1.
Well, 1.
Yeah.
This, by definition, has to be 1. Why? Now, granted, you could say why, because 1/6 times 6 equals 1. That's an easy answer, and it's a correct answer. But why will it always add up to 1, regardless of whatever numbers are in this column?
Percent has to be 100%.
Because, look at the pie charts before. And we should go back and look at the pie chart before we leave, to the die pie chart, and see what it's up to. It has to add up to 100%, because assuming you've set your distribution up correctly, we've correctly identified all the possible outcomes.
It's going to be 1?
It's got to be one of those, and it can't be more than one of those. Yes, Richie, it's got to be one of those 6 outcomes, and it can't be any more than one of those. So it's got to be 1, but it can't be any more than 1. That means it has to be 100% likely to be one and only one of those. Perfect. Lauren, go. Love it, love it. Go ahead.
I got 3.5.
Good! You should have. Watch this. This is 1, correct? That goes to 1. We can stop talking about it. All you've got to do then is you have to add up each of the data points times the probabilities. Once you've done that, you've got your average. Once you've done that, you've got your average. Now I'd like to actually stretch that. I'm going to stretch it over to here. Because I want to actually, rather than using any quick, slick mathematical techniques, I just want to actually painstakingly go through and do that. To see what's actually going on. This is where the other class almost got in a fist fight with me.